This week in the AWS Developers Podcast, we're talking about retro computing, programming for the ages, like programming language from 40 years ago. We'll explain all that. Stay tuned. Good morning, good afternoon, wherever you're joining and listening to us on this planet. We're available every Friday morning in all good podcast applications on the web, also YouTube, Spotify, Deezer, Amazon Music, Apple, and all the ones I forgot. But if it's a good app, then we're probably there. It's called the AWS Developers Podcast. And today, I told you in the intro, we are going to talk about old programming language, basic assembly for processors that don't exist anymore. And yes, there is a link to AWS. You'll see that. So I have the pleasure to welcome my colleague Ricardo Suyeras.
Very good.
We're in the same team. We know each other since many years, and we share some common history together as well. One of the common things we share in terms of history is the first computer we ever own, you and me. It's a Commodore 64. Can you explain to maybe the people that are less than 30 years old that are listening to us what is a Commodore 64?
Okay, so thank you for having me, Seb, on your podcast, and welcome everyone who's listening. So I think the Commodore 64, iconic computer of the 80s, and probably the reason why so many people ended up with careers in technology, right? But you know, it was a very different world back in the 80s. You know, pre-internet. Pretty much everything, right? But it was a very exciting time where computers had just made that kind of like shift from being something that was super expensive, inaccessible, to kind of like almost the hobbyist movement, right? Where there were literally hundreds of different computers and the price was coming down, and you know, everyday people could actually kind of reach them and start using them. And I was one of those, right? And never in a million years did I think that I would ever be able to afford or get a computer. And so when one Christmas I ended up getting a Commodore 64, I was absolutely delighted. And it was an interesting journey because I think, like a lot of people, I think I was only around maybe 11, 12 years old when I got it. And in the early kind of like times, it was all about, you know, using it to kind of understand how it worked. Not necessarily from a programming perspective, but just actually to get it to do stuff, right? Then obviously the normal path was like playing games. Absolutely. But it was interesting because through playing games, and you saw this kind of evolution of games going from pretty kind of basic and crude to becoming ever so more sophisticated, you know, better graphics, better sound. I mean, the sound was something else, right? Mm-hmm. It was just, you know, and in fact, actually, years later, when I started getting into DJing, I used to get Commodore 64 SID music, and I used to overlay it and mix it with drum and bass music for some really unique kind of like
electro,
takes, retro kind of like drum and bass, I called it. But yeah, the music was fantastic, and it was, and I think that's what really got me interested in actually thinking, you know, how do they do this, right? And you kind of get to a situation where you kind of start getting kind of bored of playing games, and then you kind of like, what we used to do as a group of people is trying to understand how these things work, how the code worked. And, you know, again, very little documentation, right? You had to go to the library.
Just one manual, one documentation with the basic programming language.
Yeah, but I tell you what, right? They don't make books like they used to, right? So the Commodore 64 reference guide, which is what everyone's Bible was, it was a thick book. But it had every little detail of the hardware, how the hardware works, all the registers, because the Commodore 64 wasn't as user-friendly from a programmer's perspective compared to others.
What was the user experience? Let's talk briefly about the form factor. It was like a keyboard,
it was like
thicker, like 3-4 centimeter with all the connectors. You connect that to your TV.
You connected it to using an RFH connection. So these don't exist anymore. Well, actually, maybe they do in some countries where typically the aerial that you get from the outside of the world that goes into your TV box. That's how we connected computers to a TV. Not a very kind of like crisp LED experience. It was an analog CRT screen, which had sometimes blurry kind of pixels, which actually was quite useful in those days because we didn't have many pixels. So to make them smoother, maybe a blurrier screen was actually pretty good. But yeah, it was.
And the user experience when you turn it on.
So literally you turn it on. You have, there's normally a hum of the power supply. You turn it on, and after a few seconds, you get a blue screen with a blinking cursor that welcomes you to Commodore 64 Basic, and that's it.
And the BASIC was the programming language, but the operating system as well. This is how you interact with the hardware, like
correct.
drives.
And so with the Commodore 64, which was different to others, you didn't have a very rich set of programming directives, right? So you had to use peek and poke.
Which are?
Yeah.
What is peek and poke?
So peek and poke is how you access the Commodore 64's registers. So, for example, if you wanted to learn how to change the color of the text or the background, these were specific registers in the system, in the Commodore 64 system. So you needed to know, first of all, what the registers were, and then what values you could use. So it was, and this is where the documentation comes in, right? So the Commodore 64 reference guide would tell you, how to do this. And this was the same for graphics, for music, for lots of things, right? For interacting with the hardware chips, which obviously today we have so many levels of abstraction, right? That now it's like, just define color equals blue, and you're done. Right.
And that's already quite low level because now you can type, what is the color?
yeah. But I think what's interesting is that you kind of like, you got a real intuition for the hardware. The Commodore 64 made you really think hard about what it was you were trying to do and how that related to physical things on the computer. So you understood the chips, what they did, the interactions between the chips. You understood that certain things could work better than others, i.e. they would take fewer process cycles or fewer hops. This is what happened the more you spent time reading about stuff. So most of them are reading materials through magazines, computer magazines, hobbyist magazines. I spent a lot of time in the library kind of borrowing books.
It's important to tell there was no Google, no internet at that time. The only way to get knowledge is talk with someone or buy a magazine or go to the library and find books.
Yeah, totally. And so actually, it's interesting that they weren't kind of like tech user groups, but they were hobbyist groups. So, the local computer shops in the town where I was, regularly, kind of 5 o'clock after the shop was closed, they would have like these kind of gatherings, and the gatherings were where people were sharing their knowledge. This is what I found out from speaking to this person, and of course, it was like a voice to voice or peer to peer kind of internet, where you heard things like third or fourth or fifth, sort of time, from other people. And that's how we kind of picked up little tricks and this is this is what a disassembler is. This is how you can use a disassembler to take a program and try and understand how it works, right? And then sometimes people would do demos and say, look, this is what I learned, this is what I've done. So I think, maybe that was influential in obviously my career where I am today, working with communities and attending tech groups and community groups, because I had exposure early on, right?
The demo that you mentioned, it was the thing at the time. It was teams trying to build the most impressive demo with the limited hardware there is in terms of graphics and sound, and they try to create something beautiful on the screen with animation and sound.
Yeah.
And teams were competing together for the most beautiful and smaller and more elegant demo.
They were trying to push the limits of feasibility of the hardware, which actually something that carried on even when the Commodore 64 passed its heyday, right? You saw that in the Amiga, in the Atari ST. You saw it even in the PCs. That they used to do .com demos. Now, for people listening, .com in that time was not the .com of the web, because the web hadn't even been invented yet, right? This was the .com of the MS-DOS command prompt, where you had limited amount of memory that you could fit within a .com file. I can't remember what it was, whether it was 32K or 64K. And so people would basically create demos which would run as a .com file, and these were absolutely crazy. They were just so cool.
What is the hardware of the Commodore 64? I think 64 was the total memory available, but we have to remove the ROM part of that. So we have 48 something.
Yeah, so it's called the Commodore
Kilobyte.
64, but like everything, right? So that's the total address space, including things like BASIC, which takes up a big chunk. The screen memory, which takes up big chunks. So you end up kind of being left with about 36, 37K for your actual programs.
Kilobytes.
Kilobytes. Oh, yeah.
Megabytes.
Kilobytes, not megabytes. Kilobytes. We're talking kilobytes, folks, which is probably less than your average Word document.
For sure. And the CPU?
So the 6502 was a processor which was very popular actually at the time. It was used in a number of computers, so starting from the VIC-20, Commodore 64, the BBC Micro, and a few others. Right? It was, and there was a competing processor at the time. You were either in the 6502 camp or the Z80 camp. So ZX Spectrum, Amstrad CPC 64, a few others as well. But I had a Commodore 64. I did also, later on, I got a Dragon 32, which also used a 6502 processor. But really so that was the actual, the processor operation codes, right? So that's the kind of how you interacted with the machine. But what made machines different, okay, was the kind of the corresponding chips and processors they had. So the VIC was the graphics processor of the Commodore 64. You had the SID chip, which was the music processor. And actually, the Commodore 64 music processor was way, way ahead of its time. I mean, even today, right? So in the last couple of years, I've started dabbling into creating electronic music. Okay, so I have a machine. I have I can't remember the name of the tool now. It's a DAW. Basically, DAW is a digital audio workspace. Ableton, that's it. It's Ableton Live 11, and you can plug in various kind of virtual synthesizers. So I have a Mini Nova physical one. I have a Mini Nova virtual one, which I can plug into my DAW, and then basically through a dumb keyboard start programming it as if it was a keyboard. People have created Commodore 64. A virtual synthesizer, VSTs they're called, which you plug in and then you program and you can make music as if it sounds like the Commodore 64. I mean, it's still
so iconic.
Yeah, and people still create certain. There's actually meetups you can go to where they actually just do nothing but play Commodore 64 music. In fact, I have to say, I have a YouTube video. My most watched YouTube video is I think it's 11 hours long, right? And it's just basically back to back Commodore 64 music being played by all the greats. So you've got Rob Hubbard, Ben Dalglish, Martin Whitaker, right? These are the most amazing musicians that were able to produce sounds from the Commodore 64 that just were literally unbelievable, right? And they've stood the test of time, because 40 years later, right, you still listen to them, you still think, wow, right? And it's incredible. But I think so going from back to where we were.
Going back to hardware, we talk about the memory, the CPU. There was no storage at the time; it was optional. You had to plug an external. There was storage. No persistent storage, no disk.
There was floppy. There was tape cassettes.
But it was optional.
No, well, you couldn't really do anything without it, right? So the minimum viable system you had was a floppy disk. Was a cassette.
A tape.
Yeah, it was a tape. And so you would literally either save programs you were writing to the cassette, and then load them back. If you were rich, okay, you had a floppy disk.
You have a floppy disk. I
had a floppy disk.
But I start without one, and without tape as well. So it means when I power off the machine, I lost everything I did. And it was the time, as you said, I was buying a magazine, typing games, so a series of poke instructions, typing for 1 hour or two, and then I have to play with that game and nothing else. I can turn off the computer, otherwise I have to type everything again.
Yeah.
Then yes, a bit later I managed to buy a floppy disk.
Oh wow! Yeah, I never got to floppy disk. I had tapes, but I think during that time, what was interesting, okay, is that, like I said, there was very little information, so you had to spend a lot of time looking for that information. But But what was interesting is that as I started getting bored of playing games and wanted to actually think about how to write them, the first thing I thought is, well, I've got all these games. Why don't I try and see how they work? Okay, and so that led me down a rabbit hole, which I probably lost a few years, and started learning about things called disassemblers. So disassemblers, for people who may not be familiar, is when you run a program. So let's say, for example, I run a program in Python. Python is a interpretive language. The Python interpreter will turn that into instructions that the actual underlying machine will understand. So the ones and zeros. So in hexadecimal or ones and zeros, that the machine it runs on knows what to do. So it might for example, display a pixel on the screen or echo a sound on the speaker. And the same is true on the Commodore 64, right? So what we would do is we would have these games which were already compiled and in machine code, and we would use a thing called a disassembler, and a disassembler would attempt to reverse engineer the ones and zeros effectively into assembly language, right? So assembly language is like the first higher level language that allows you to do stuff programmatically. And then obviously on top of you've also got basic, which is even higher level, right? So we would take these or these games, we would reverse engineer them, and we start getting all this like stuff which we didn't understand, right? And this is where again the books came in. So we had a number of books like the Commodore 64 reference guide, which actually explained what these assembler opcodes were, what they did. And we're talking very basic, right? We're talking, 3 registers, the ability to add and subtract, do some logical operations, do some compares. You can do some subroutines to jump. But you had to do all the memory management yourself, right? And you were operating at a really, really low level. So in the early days, it was literally just trying to make a program do something like write some stuff on the screen, maybe move some sprites around. Maybe create a scrolling routine, right? And that felt like a huge achievement because the performance difference, was just so huge from
compared
doing
to
basic
Mm-hmm.
to doing assembler. And that's why basically we were doing it, because we tried doing it in basic, and even though you had kind of like, or it felt like you were kind of interacting directly with the hardware, with the peaks and the pokes and the sys's to run it, it still had to go through, I guess, lots of layers of abstraction, which meant it was still slow. Right, and when you did an assembler, it just went so much quicker. It was just like chalk and cheese. And actually, I recently demonstrated this. I did a blog post, which actually I guess is why we're here.
Yeah, exactly. You might wonder, if you're listening to this episode, why are we talking about Commodore 64 in the AWS Developers Podcast, and where it's going, this conversation. Actually, Rick, for the last year or so, you're working a lot with Amazon Q Developer, that assistant that you can install inside your IDE, that you can chat with to ask questions. It can generate code for you. And you had that crazy idea, and you start with the idea. Is this thing, Amazon Q Developer, able to generate not modern code, but code from 40 years ago, basic for the Commodore 64? Where this idea came from? Why?
Right, well, that is
what
exactly
are you doing at night?
So I would love to claim the credit myself, right? But the idea actually came from the developers I speak with, right? So I've been speaking and doing lots of sessions with Amazon Q, and I've lost count of how many meetups or how many events or conferences I've done. But one of my most recent popular talks I do is where I literally start with nothing. Okay, I'm on the stage. I have a blank IDE, and I try and build something in 30 minutes that works. And it's interesting because it generates a lot of interest and a consistent theme. Okay. When after I finish the talk and people come up and they ask me questions is, will it work with this programming language? Will it work with Ruby? Will it work with C#? And I say, yeah, it absolutely will work with all of those things, right? And then I think it was a recent one where I don't know how we were all talking about retro computing, and someone said, have you tried using Q to create code for the Commodore 64? And I said I haven't. I said, but I'm confident that it will. It will. And I said, the reason why I think it's confident, the reason why I was confident is that the Commodore 64, unlike maybe some of the other 8-bit computers out there, retained a very loyal following. Okay, and in fact, even today, people are still producing source code and release games, for the Commodore 64. I mean, I don't think they might be being charged minimum amounts of money, but the scene is still very healthy, very active. And I'm a member of a few of the retro groups, okay? And so what I said is that, if you think about how the underlying large language models are trained through the corpus of information on the internet, there's going to be a good chunk of information out there on 6502 assembler because, like I said, multiple computers use that. It wasn't just the Commodore 64. So as a kind of like a bunch of information out there on how to do 6502 assembly, there's a lot of stuff out there. How to do 64 specific assembly with things like sprites, music, there'll be maybe a lot less, but it's going to be out there. So I felt confident that it could do something, right? So I went away, and in those moments where, those rare moments we have, Seb, as you know, we're in the same team. In those rare moments where we have a minute to think, okay, I thought, let's try
when we wait for a plane in an airport.
Yeah, exactly. Normally it's at an airport, right? So I tried it. And what I did is I initially thought, okay, first of all, I've got a Macintosh. How am I going to do this? Right. So
then you run a Commodore 64 BASIC on your Mac.
Yeah, exactly. So how do you do this, right? And the good news for anyone interested in maybe doing this is that, I mean, I'm focusing on the Commodore 64, but there are other 8-bit computers out there as well, right? But the actual emulators that, effectively allow you to run a virtual Commodore 64 on any computer, okay, they're very polished. They're very reliable. They work really, really well. And the one I'm using is called Vice 64, which is probably one of the... Yeah.
And they can distribute the original ROM from the Commodore 64, or you have to hack that from somewhere else?
That's a good question. I don't know about the legalities of that, actually, because it comes as a installation package.
Okay, with everything. You don't need to download the ROM separately.
I don't need to source the ROMs separately, right? So I'm guessing someone at some point has made the decision that we can make this available. It's a good question, actually. I don't know.
And so you have an app, and when you start the app, you have the blue screen, which is not the blue screen of the blue screen of the Commodore 64, and you can start typing BASIC and interact with the machine.
You can do all of that, and it's fantastic. And it comes with a whole. And so I've been using Vice 64 for a long, long time. Okay, so at least 10 years. But what's interesting is that over the years, it's become more polished. It's become certainly more reliable, but it's also started bolting on some really cool new features, especially for tinkerers like me that want to kind of like do things. So, as an example, you can mount a local drive as a virtual floppy disk, which means that if you're writing programs, it's very easy to load them in the emulator. So, but obviously having the Vice 64 running on my Mac is only part of what the thing, right? So, but it allows you to run and load existing programs.
So you start to write program, or to ask Amazon Q to write program for you?
Yes, we know where this is going. So the first thing I ask, Amazon Q, is that, and so for people who don't know who don't know what Amazon Q Developer is, it is a plugin you can install in your IDE. So IntelliJ, VS Code, Visual Studio have got plugins. And we do have Eclipse coming soon. And you get, once you've installed and configured the agent, you can log in using one of two ways: a Builder ID or an AWS professional tier IDC account. But most people use Builder ID at the moment just to experiment with it. And you get this kind of like chat window, right? And you can ask it questions like you can with lots of these foundational models. And so I started saying, do you know how to program in the Commodore 64? And it said yes.
Yeah, I can.
It said yes. It said yes. So I got excited, and then I started saying, I started asking questions. If I want to program Commodore 64 on my Mac, what tooling do I need, right? And that's where the first rabbit hole came, right? And it gave me all this really good information. And I started, and because I use VS Code, the first thing Q told me to do was install Kick Assembler, right? So Kick Assembler, there's lots of different assemblers. So actually, let's roll back a bit, okay? So because we kind of, I talked about disassembly, okay, and from the Commodore 64, we all started on BASIC to run programs. But the next step, what developers used to do was actually write assembler code.
Assembly language.
Okay, and what this means is you write code in the same way as you write a basic program, but there's an extra step. You have to compile the code, okay, so that it can run. So typically, it will generate an executable file. And so you need an assembler to do that. And obviously the disassembler piece is what I talked about earlier on, is how you reverse engineer that code. Mm-hmm. Okay. And so I kind of so Kick Assembler was the recommended VS Code assembler for Mac. There are others. I think the most common one is called ASM, which I'm not sure if it runs on Macs, but a lot of the tooling actually, to be fair, is Windows based. And actually, Sorry.
So you install a new extension in your VS Code that is able to read, understand, and compile assembly language to binary machine?
So
code?
not quite. So first of all,
not yet.
So not quite. So what happens? Okay, is that Kick Assembler is a Java program. So because I use Amazon Corretto, so again for folks who aren't familiar, Amazon Corretto is Amazon's OpenJDK distribution. It's awesome. It's one of my favorite open source projects. It really is so good. And so I have that running on my machine. So that wasn't a problem. I installed Kick Assembler locally, and it's literally just a zip file, right? So you find a directory, you unzip it, and you've got now Kick Assembler running as a bunch of jar files. So you then install the Kick Assembler VS Code plugin, and in the configuration you point to these jar files, okay, but you also point to the VI64 executable, so that it knows how to launch it, and there's a bunch of other stuff you configure. So there's a debugger, there's a C6502 debugger, which again you need to install in a directory and point the VS Code plugin to. But you get to a situation where you now are in VS Code. Okay, I have this plugin, okay, called Kick Assembler, and I have a whole bunch of these programs that this plugin will use. So Vice64 for the emulator, the Kick Assembler for the compiler,
and the
debugger for the debugger, right? And I then open a project, and I first of all I go simple first, right? I ask you, can you write me a program that moves a sprite, okay, on the screen? Now, for folks who aren't familiar what sprites are...
It's an icon, a little graphic, like 8-bit graphic, something. Yeah.
It's a graphic, but what's unique about this is not all 8-bit computers had sprites, okay? It's part of the VIC-2 chip that allows you to generate 8 hardware sprites, and they've got different characteristics, right? So they're either in low-res or high-res mode. High-res mode, you have nicer pixels. Low-res mode, you have multicolor, right? So you have to make a choice, right? Do I have
color,
two colors or
high
color?
resolution?
Yeah, exactly. But you can only have eight of them. And so
what is high resolution? It's like 8x8 or 16x16, something like that?
It's not 8x8.
It's smaller than that.
I think it's higher than that. I think it's 16 by. Is it 16 by 16? I think it's 16 by 16.
But that's the roughly the size we are talking about.
Yeah,
okay.
Yeah. I mean, I should know that because I've been playing around with it the last few weeks. But I've stopped now because it's too addictive.
You have to work.
So I got Q to write this program for me, and I actually have written a blog about it, so we can maybe share it in the
it's
podcast
in the
notes.
note of this episode. So you just scroll down in your podcast app, and you will see the link to the blog post.
Thank you. And so the first thing, okay, is that the first thing I realised is that it's really easy to take source code that Amazon Q generates and just paste it into the Commodore 64 screen, right? So Vice supports paste, right? Which is fantastic. So, I can type
that's
on my
not
Mac.
obvious. It's obvious when you say copy paste, but if we think about how it works, there was no copy paste on this machine at the time.
Exactly,
so it's the emulator that has to simulate keyboard input.
Yeah.
And it works.
Well,
the code
not quite.
That was generated.
Not quite, because the first thing, right, was that Q made everything uppercase. And so when I pasted it into the Commodore 64, it just gave me all the extended characters, okay? And so it looked like garbage. It looked like junk. And so I thought, I asked Q, this isn't working, and then Q said, oh yeah, sorry, it needs to be lowercase, right? And so it gave me the code again in lowercase, and sure enough, the second time it worked. I ran it, and I had sprites running on the screen. They were very slow though. They were really, really slow. So it would literally...
It was not assembly language at this stage.
No, this was basic.
It was basic with
just
pokes
pure
and peak.
basic.
Mm-hmm,
Yeah,
okay.
yeah. And all I did was basically move the sprites in a just. I think I might have even just displayed them, and then I thought, okay, let's change the code. I asked Q to then basically say, can bounce the sprites across the screen. Okay, and sure enough, it did. It worked fine. Okay, and but again, it was really slow. And I've in the blog post, if folks are interested, you can see how slow, because I've recorded some videos, right? And it's painfully slow. Yeah, it's really, really slow. And of course, at this point now, memories are flooding back. I'm thinking, God, I remember, we used to do this, and let's see, if we can, get Q to write or convert the program from BASIC to assembler. And the long and short of it, without any spoilers for people who want to read the blog post, is it worked. Okay.
But you basically said, can you convert this basic program into 6502 assembly? And boops.
Exactly. And
and voila.
It was literally that simple. It was that simple. And it worked. Now, so I say it worked. So, like I mentioned, when you're programming assembly language, you're effectively writing the 6502 mnemonics. So this is the codes like LDA, STA, jump, all that kind of stuff. But every compiler out there has its own set of, latent norms. Okay, so a good example, is comments, or how you define
indentation,
a routine. Yeah, exactly. And so what I realised is that a lot of the code out there, that I guess the training material is on, has over-indexed on either ASM or other. There's probably the most well-known compiler for the Commodore 64 Retro is called the CBM PRG compiler. It's an Eclipse type tool that runs on Windows, doesn't run on Macs. So of course a lot of the source code initially came out in that format, and it wouldn't compile. Right, but again, this is why I've become so addicted to using Amazon Q, because I had an error message, and I used Q to help me understand what the problem was, and it said, oh yeah, it looks like this is this is expecting ASM as your compiler, and you're using Kick Assembly. Because when you're having a conversation, it's really important that folks know is that the context and the history and memory of that conversation is kept by Q. So it already knew that I had recommended Kick Assembly, and I'd installed it, and so it kind of like maybe it could have done a better job initially of giving me code for that compiler. It's not perfect by any means, but I was very easily able to get Q to convert the assembly it had into Kick Assembler format. Yeah, and then once I did that, it's a really great experience. In VS Code, you press F6, it compiles, debugs, and then brings up Vi64, and I had these 3 sprites running. And again, you'll see on the video, I spent a bit of time on the Sprite Man, which is an online tool to create sprites of the AWS
yeah,
logo.
You even create your own sprite to give to the application.
I did, yeah.
So you found a tool that is able to generate the correct file format there.
So that's actually where I'm currently. At this point, I thought, how much more time do I spend on this, right? Because, I found myself, balancing a bunch of kind of concrete timelines. I had 3. So I've been at three sessions or three talks. This week, a couple of talks last week, and I knew that I had to do those talks and those workshops, right? But I became so hooked on wanting to do more and see how far could I push this. So anyway, initially I just wrote the blog post because I just wanted to share. I thought it was quite interesting that for an old computer, you could still use tools like Amazon Q. And I was beginning to think of, the use cases and the potential for this, right? Because, there are, and actually, kind of another motivation was I read a statistic. There was a YouTube video from the founders of Anthropic. Actually, I think I'm not sure if it was them or someone else on the video, but they said that in the last 12 months, they've seen some interesting data points around adoption and usage of programming languages. Okay, so a good one is PHP. Now, I don't do PHP. I used to do PHP a lot, right? And PHP has been steadily declining, right, in usage.
The usage, yeah.
But the last year, it's not been declining. It's been increasing. Right.
And it's thanks to the generative AI assistant?
That's one potential. I mean, no one knows for sure, right? But one can speculate that might be the reason, because PHP is a very, very stable language, okay? And it's very well known. There's a lot of information out there. And so the gap between someone who uses PHP versus developing it is actually quite big. I used to speak to lots of, Drupal or WordPress developers that wouldn't write their own modules because, it was just, beyond their capabilities. But maybe now, it's people are now taking that first leap. And so I think that was kind of what led me to kind of like, again, try this, because I think, old programming languages we've got, or stable ones, I think are very much within the scope of these tools like Amazon Q, right? Where they can you can use them either to, update them, work with them, or even maybe, upgrade them to a different language. I haven't tried, getting it to convert my 6502 assembler to maybe, the Intel equivalent, right, or the ARM equivalent.
So you might convert that experience, that blog post, this podcast, to a talk, and maybe we have a chance to see you next year in 2025 somewhere on the stage. Definitely. Demonstrating that.
Yeah, I if people are interested, I would definitely do a 6502 Commodore 64 assembly, talk. But what's interesting, I wrote the post and shared it, and I was very surprised at the reaction, actually, because it hit the first page of Hacker News, which is the first time it's happened to me. And
a lot of visibility there.
A lot of visibility, but interestingly, I did read it, and what most of the discussion was more on the incorrect use of assembler, or whether is it assembly language, which is a fair point. Okay, I totally accept that. I maybe used the wrong language.
That's so typical from Hacker News.
It is,
so
but it's great. I think so it's interesting because every subsequent thing I've written afterwards, I've used the correct terminology. So you do learn, right? As long as you're open to learning, you do learn. But then it also appeared on Hackaday and a few other places, right? And I was really, really quite shocked. But the most interesting feedback I got was on Reddit, and this one person said, "This looks really cool, but have you tried using Q to write a sprite multiplexer?" Okay,
what is a multiplexer?
Yeah, so exactly, what's a sprite multiplexer? So the Commodore 64, I've already mentioned, has sprites, but it only has 8 of them. Right, which can be a limitation. If you want to build a game, you typically have more than 8 moving things, right? And in the kind of like mid 80s, the supreme coding geniuses, are, the kind of bedroom coders, figured out how to break this limit. Okay, and you had games that had like 30 or 40 sprites, and you were thinking, how are they doing this? This is crazy. It's impossible to do, and yet these people were doing the impossible. And so at the time, kind of, it was like a very well kept secret. And you could disassemble games and you could try and figure it out. Obviously, 40 years later,
it's well documented.
It's very well documented, right? It's very well documented. Now, my initial attempts at doing or using Q to write one off the bat weren't successful. Okay, and I think it's because it's a very complex problem. And one of the things that I always kind of urge people to think about when they're using coding tools like Q is that, and one of our colleagues, Massimo, he's documented this, that there are 2 sweet spots for using these tools, right? What he calls boost and learn. Boost is where you know something and you use these tools to improve your productivity. And learn is where you know something already and you can use it to improve your learning of something. But go too far either way, ask it to do too much, or ask it to do something that you know nothing about. These are the danger zones, right? Where you tend to get less return. Maybe we can share that the blog post that Massimo did in the notes as well, because it's well worth people reading about that. And so I felt that asking it to do a sprite multiplexer was probably by itself was too much. But what was interesting, okay, is that Q did know it needed to create one, because when I said update my assembler code so that I can have 12 sprites running, it immediately knew that, okay, I need to create a sprite multiplexer. But the code it generated whilst working was not great. So what I mean by that is it compiled, which is good start, but the code flickered and glitched. Now, yeah. So I spent probably way too long over a weekend reading, and this is where I found the amazing Commodore 64 community is thriving. There are so many amazing people creating content on this, and they are literally doing like 1 hour, 2 hour YouTube videos where they are writing sprite multiplexers, or they blog post about it. And so I watched a few of these, found a repo with some code, and I went back to Q with my original code, and I presented, here is some code that does sprite multiplexing. Update the code to do it. And so again, I was in the airport yesterday. Actually, I had I was 3 hours early. Well, actually, the flame was an hour late, so I was I had about an hour and a half to kill. And so I was, I was using the Wi-Fi on the airport, so it wasn't particularly good. And I just sat there, okay. And in about 30 minutes, I was able to take the code from this. It wasn't really a code; it was like a routine, a subroutine, and incorporate that. And I tried 16 sprites, 22 sprites, 30 sprites, and it worked. And I had all these sprites running on my virtual Commodore 64, and it was amazing. And then I started basically changing the code so that it would like change the order in which the sprites were moving and all that kind of stuff. And I was just absolutely blown away that, there's no way that I could have done that without spending significantly long time
in such amount of time.
Yeah. Exactly. And actually, going back to some of the conversations I have with developers, a common person attends my workshops and talks, right? And these are developers who no longer develop. They typically are they're engineering managers, they're IT directors. Okay, they used to develop on a regular basis. Now they manage developers, right? And they say, no, we want to get back into development, and we think these tools can help us get back into development. And I thought that was really cool, right? The fact that
exactly,
because they already know and understand programming. I think these tools are perfect because they operate in that sweet spot of you understanding the domain and you now orchestrating. So you can understand what to tell it, and you can also review and know how to take the output and do something with it. Right.
And what this tool did for you with all programming language, assembly and basic, it can do also probably even better with modern programming language right now.
Totally.
If you're programming
absolutely.
in TypeScript, in Python, in Java, it can help you as well. How to get started with Amazon Q? If I want to try it in my IDE.
So what you need to do, first of all, is grab a Builder ID. Okay, so we'll share a link to the Builder ID in the notes.
So it's a free account, no credit card required.
Absolutely. All you need is an email address, and you can sign up. And there's other benefits as well. There's a whole bunch of skills courses you can do. You can access and create content on community.aws. So it's more than just this, but so there's more great things you can use with Builder ID. So once you've got your Builder ID, you then go into VS Code Marketplace or the one in IntelliJ. Find Amazon Q in the search bar, install it, and then sign in using your Builder ID, and then you're set. You're done. You can start using it. It's as simple as that.
And there is a chat icon in the IDE that appears where you can ask your question and interact with your files and copy paste files.
Yeah,
or generate code from.
There's three. Actually, there's so just for so folks know, you have the chat window, which is great, but you also have the kind of in file, so we call it inline experience. So when you're creating a file, you also have it actually there in the actual file. So you can either do, for example, you can type in a prompt using a comment, hit return, and it will start generating code for you as well. And it's also it's actually embedded into the actual VS Code IntelliJ menus as well. So it's deeply integrated into it. So the idea is to make it really easy for you to use as a developer.
Try it today, and maybe if you have the nostalgia of retro programming and old programming language, maybe they can help you to go back in times to the mid 80s, early 90s, where you were yourself programming these on Commodore 64, and then all the others that came after that one. Thank you, Rick, for sharing your passion about that. It was fascinating listening to you. Thank you, you, having listened this episode until the end. Next Friday, we are going to talk about the 10 things you need to do when you have a new AWS account in terms of security, of automation, what are the basic configuration. That will be like a laundry list of the 10 things you have to think about when you receive a new AWS account. It will be available Friday morning in all your podcast application. But now, go build.